And we're back to conclude 18-4, where we're dealing with the spontaneity of reactions. In the last podcast, we introduced you to the idea of free energy. The idea of free energy being that it's the maximum amount of useful work that's available to a system. And so when delta G is negative, a reaction is spontaneous. When delta G is positive, it is not going to be spontaneous. In fact, the reverse reaction would be spontaneous. And when delta G is equal to 0, you're at equilibrium. And so we compared several scenarios where we took a look at the signs of delta H and delta S, and we predicted whether or not a reaction would be spontaneous. We showed where delta H and delta S, if they're both favorable, as in this case right here, if delta H and delta S are both favorable, the reaction is always spontaneous. If neither of them are favorable, meaning it's endothermic and creates more order, it's never spontaneous. However, when one suggests that it could be spontaneous while the other does not, it is going to be temperature dependent. And so we were looking at two scenarios where we already understand that the process is temperature dependent. Will water freeze? Well, it depends. If the temperature is low enough, water will freeze. Will water boil? Well, it depends. If the temperature is high enough, it will boil. And so we were showing you in terms of delta H and delta S why this is the case. We said that with the water freezing, it's an exothermic process, so delta H is negative. I'll change colors here. And then because you're creating order or less randomness, that is not favorable, delta S is negative, but that whole term will become positive. So is this going to be spontaneous? Well, in order for this to be spontaneous, the temperature, this, must be lower than this. This must be higher. So how do you create this to be lower than this? You have to have lower temperatures. And at lower temperatures, delta G will be negative. The reverse reaction, which is the melting, would be spontaneous at high temperatures. We did the same thing with boiling of water. We showed you the sign of delta H, the sign of delta S, and so now, again, we have one positive, we have one negative, and so in order for this delta G to be negative, this must be higher than this. Well, how do you make sure that this is higher? You have to have higher temperatures. So it is spontaneous at higher temperatures, and you already know that. Boiling water is spontaneous at high temperatures. And of course, the reverse reaction, which would be the condensing, is spontaneous at low temperatures. Alright, so let's go ahead and try some problems here to see whether or not we can predict if a reaction will in fact be spontaneous. So determine whether the following reactions would be spontaneous, non-spontaneous, or temperature dependent. Alright, a reaction in which a solid produces a gas. Well, is a solid producing a gas favorable? Yes, because delta S is going to be positive. And that's a good thing, to create more randomness. And it also releases heat, which means that delta H will be negative. Both of those are favorable, so therefore this reaction is spontaneous. Now we have a reaction in which a liquid forms a gas. Well, once again, you're going from a more ordered to a less ordered state. So delta S will be positive. That's a good thing. You want to create more randomness. But then energy is absorbed. Well, if energy is absorbed, delta H will also be positive. That's not good in terms of spontaneity. So if you have one that says that it is and one that says that it isn't, it is going to be temperature dependent. In letter C, a reaction in which a liquid turns into a solid. Well, that's not favorable because you're creating order, and that is energetically not a favorable situation. But energy is released, so delta H is also negative. So you have the enthalpy is favorable, the entropy is not. Again, temperature dependent. And finally, a reaction in which several gases form a solid. Well, if gases are forming a solid, it's becoming less random. So delta S is negative, not good. And it absorbs, we have an E here, shouldn't be there. It absorbs energy, which means that the delta H is positive. That is also not favorable. And so since neither of these are favorable, the reaction will be non-spontaneous under all conditions. Alright, so you should be familiar with spontaneity versus non-spontaneity, enthalpy, entropy, and free energy, and you should be able to predict the signs on all of those terms and predict whether or not something will be spontaneous, non-spontaneous, or temperature dependent. That concludes 18-4.